හරි. බයෝමොලිකියුල්ස් පාර්ට් එක. හරිද? MCQs ටික කරන්න මේ බයෝමොලිකියුල්ස් එක ඉන්ඩස්ට්‍රියල් එකයි රික්වෙස්ට් කරලා තිබ්බා. හරි. ඕනෙව රික්වෙස්ට් කරන්න. ක්ලාස් 9 ළමයින්වත් අවුලක් නැහැ. රික්වෙස්ට් කරන්න මම දන්නවා කොහොමද අන්තිමට එකේ ක්ලාස් එකේ නැති ළමයි ටිකත් මේක බලනවා. හරි. ගොඩක් කාට ගොඩ දා ගන්නවා පේපර් ඩිස්කෂන් ටිකෙනුයි පාස්ට් රිවිෂන් ටිකෙනුයි ඊට පස්සේ PPC ඩිස්කෂන් ටිකෙනුයි ඔය ටිකෙන් ගොඩ දාගන්න ගොඩක් ළමයි ඉන්නවා. හරි. මේක ක්ලාස් 9ට කමන්නේ මම ඔය ටික පබ්ලික් දාලා තියෙන්නේ. ඒ ටික බලලා හරි මැච් එකක් ගහගන්න ඕනේ. ඒ ටික හරි ඒ ටිකෙන් හරි ගේමක් ගහගන්න ඉතින් නේද? හරි. එතකොට right, biomolecules. Vitamins required to control calcium absorption and blood clotting are respectively. හරි. එතකොට මේකේ තියෙන විටමින්ස් වගුවක් නේද? ඔය විටමින්ස් වගුව අනිවාර්යෙන් එක්සෑම් එකට යන්න කලින් දවසේ රෑ අනිවාර්යෙන් බලන්න. හරි. විටමින්ස් වගුව එක්සෑම් එකට යන්න කලින් දවසේ රෑ අනිවාර්යෙන් බලන්න. මොකද ඒ ටිකෙන් MCQ එකක් හරි දෙකක් හරි අනිවාර්යෙන් එන්න තියෙන chance එක වැඩි. ඒකයි මම අර කිව්වා biomolecules වල. There are a few not under the biomolecules. Yeah, it is under the biomolecules. Under the biomolecules, I have said that there are few of the enzymes and their industries and the things that happens in the the function of that enzyme in the industry were given. So if you check that that it's not a table, I have given separately the enzymes, it's in the industry and what it does. So if you check that separately, you will get at least like one MCQ out of that too. So it is something you should study the day before or the night before the exam day, right? Something to study the night before the exam day. So enzymes ටිකයි industries ටිකයි ATK functions ටිකයි. හරි. ඊට පස්සේ vitamins table එක. ඒක අනිවාර්යෙන් exam එකට කලින් දවසේ බලන්න ඕන. ඊට පස්සේ ආපහු තියෙනව මොනවාද? ඔය මොනවාද? natural products වල extractions ටිකක් තියෙන්නේ. ඔය eugenol, gingerol අන්න ඒ සෙට් එක බලා ගන්න tables ටික. මොනවාද ඒගොල්ලන්ගේ base compounds මොනවාද extract කරන්නේ? ඒගොල්ලන්ගේ functions මොනවාද? ඒ ටික අනිවාර්යෙන් බලා ගන්න. Right, බලන්න. Out of the vitamins required to control calcium absorption and blood clotting respectively. So out of these Usually vitamin K is responsible for blood clotting, and for the calcium absorption, it's vitamin D. So vitamin D and K probably. We'll check the table as well. Vitamin D, calcium absorption, phosphorus absorption, and vitamin K, yeah, blood clotting, to produce blood clotting factors. Anything else related to it? No, right? No. So yeah, so the answer is vitamins required to control calcium absorption and blood clotting are vitamin D, are responsible to absorb calcium and phosphates, and vitamin K is responsible for blood clotting, and vitamin C is also something related. You'll check vitamin C for a healthy skin, to produce collagen fibers. Okay, and vitamin C, yeah. So the actions of vitamin C is given like even bleeding gums are one of a deficiency uh, of vitamin C, but it's not about the blood clotting. So bleeding gum is one of a deficiency symptom in of vitamin C, but it's not related to the blood clotting. So the actions of vitamin C is given healthy skin, to absorb no, to produce or to synthesize collagen fibers is given. So right, it's D and K anyways. Functional groups available in biomolecules, uh, denoted as A and B, are shown in the table given. Biomolecule A, functional group only COOH group is there, right? And in the biomolecule B, only COOH and NH2 groups are there. Which of the following biomolecule represent A and B in order, right? So if only COOH group is present, that could be a fatty acid, because fatty acid is something like this. C double bond O, OH becomes the head, and there's a long tail of hydrocarbon, and this is a fatty acid, right? These fatty acids are there in oils. So we consider these fatty acids under the soap production and even in the biodiesel production, because in biodiesel production and soap production both we use these oils, right? But COOH is present in fatty acids, so fatty acids can be taken, but in glucose, no, it's ketones or the aldehydes that are present in glucose. Amino acids is basically the both COOH and NH2 both. So the first answer should be fatty acid A. So 3 and 4 answers are true. And when it comes to B, only COOH and NH2 are available, that is amino acid. So answer should be fatty acid and amino acid, right? So fatty acids are something like this, and the amino acids are something like this. So amino acids are like this COOH group there, then alpha carbon, right? Then in alpha carbon there's a hydrogen and an R group, and there's a NH2 group attached to this alpha carbon as well, right? So this is amino acid. So amino acid contains NH2 and COOH. Fatty acid contains COOH, right? Okay. Third question. Consider the following statements about enzymes. So this is under biomolecules, right? Under the biomolecules, there's part called enzymes under the proteins. So it's there. Activity of an enzyme is independent on the pH value of the medium. No, the enzyme activity depends on the pH. This is wrong. Activity of an enzyme depends on its specific three-dimensional shape. We discussed this as a lock and key method. So specificity of an enzyme is that it can only catalyze one reaction, because it gives an active surface to a certain shape to join, right? It gives an active shape to a certain molecule to join, that you call substrate. The molecule is substrate, and the active site is actually the enzyme. So it's like a mold. the enzyme is like a mold. So two of the things are coming down and settled in this mold, and the mold presses it. When the mold press it, the reaction occurs, and the product is produced. So that is called like, so the shapes of the, let's say this mold is round, so none of the squares can be fit in, right? So that's a specificity, right? That's a specificity. So activity of an enzyme, something like this. So let's say two of the round shapes can join this, right? If two of the round shapes can join this, right, to produce something like this. One of the square shapes can join here, right? One of the square shapes can join this. So like, which means this is specific to this, right? This enzyme, this is the enzyme now. This is the enzyme, right? And this is the substrate, and this enzyme, and this is the active site. This is the active site. This part of it is called the active site. So this active site of the enzyme is only specific to substrate. It's like lock and key. So the enzyme becomes a lock and the substrate becomes a key. So it's like a lock and key. So one enzyme can only catalyze one sort of a reaction. That is called the specificity of enzymes. So activity of an enzyme depends on its specificity in three-dimensional space. That is of course true, right? That is true. See, most enzymes are, hold on for a second. Right. Most enzymes are active between 5 degrees of Celsius to 40 degrees of Celsius range of temperature. Of the above, the correct statements, yeah, most of the enzymes are active between 5 to 40, like, because most of the live things are there in between 5 to 40. Most of them, like majority of the live things are there between 5 degrees and 40 degrees of Celsius, and below the 5 and above 40, most of the livings will die. So of course most of the enzymes are active between 5 to 40. Can take, yes, sure. So answer C is even correct. So like, I'm just telling my answers as per my perception, and you can argue any of the answers with me, and even the past paper answers can be different from what I'm saying, and you can argue that as well. So we'll argue to get the correct answer. That's the best way. I'm just not copying the answers who have somebody have answered and telling it to you. So we'll do it that way, right? So as per me, B and C are the only answers. BC only, right? BC. Which compound can be used as a raw material for the production of biodiesel, right? Which compound can be used as a raw material for the production of biodiesel? So production of biodiesel, the main two raw materials are methanol, one of a alcohol, and oil, right? Oil and alcohol are the two materials. So it's most of the alcohol that are used are ethanol and methanol, and out of ethanol and methanol is the most used alcohol because the chain should be short. So which compound can be used as a raw material is, like, oils are basically triglycerides, right? Oils are basically triglycerides. Triglycerides are two types. One is the fat, the other one is the oil. So for the biodiesel production, we use triglyceride, that is oil, right? Oil, plant oils mostly, right? Yeah, so that's the raw material. 5. Lactose belong to which group if carbohydrates? Lactose. So lactose is the milk, sorry, the sugar that there's in milk, right? Lactose is the sugar that is there in milk, right? Lactose is the sugar that is there in milk, and it is a disaccharide. Like, 3 of the disaccharides are there, which are made of hexose monomers. like we'll come from the beginning. So if we think of the sugars, the simple sugars are two types. We discuss them as monosaccharides and disaccharides. They are both sugars and they are simple sugars. And disaccharides are actually made of monosaccharides, right? Disaccharides are actually made of monosaccharides. And monosaccharides are many types, right? Monosaccharides are many types. Depending on the number of carbons, there are huge variety of monosaccharides, uh, which derive from which range from carbon 3 to carbon 7, right? Which range from carbon 3 to 7. There are many number of monosaccharides, but like the majority of those monosaccharides are hexoses, like which have 6 carbons, right? There are many monosaccharides from carbon number 3 to 7, but out of that, carbon 6 monosaccharides, so carbon 6 molecules are the highest number. So these carbon 6 molecules or the hexoses are basically 3 types, right? Basically 3 types. Those are called glucose, fructose and galactose, right? Glucose, fructose and galactose. And for these glucose, fructose and galactose, they have alpha and beta conformations or different arrangements. Alpha is an arrangement where the OH group of the first carbon is below the plate, right? We call it conformation. And beta is a conformation where the OH of the first carbon is above the plate, right? You're supposed to know those by now. So there are alpha glucose, there are beta glucose, there are alpha fructose, there are beta fructose, there are alpha galactose, and there are beta galactose, and you're supposed to know the shapes of them as well. You're supposed to know to draw them as well, right? Okay. Right. So lactose belong to which group? Lactose is a disaccharide produced combining two of those monosaccharides. So lactose is basically glucose and galactose, and it's made of both beta glucose and beta galactose. Beta galactose and beta glucose together is producing lactose, and it is a disaccharide. Lactose is a disaccharide, right? Lactose is a disaccharide. So the information I said you should have studied it by now, should have remembered it by now. And if you don't, go through the recordings, these biomolecules, right? Go through the biomolecule recordings, you will understand it, right? Okay, come to the sixth question. 2 monosaccharides present in beetroot. So it's basically sweet in taste, right? Beetroot are sweet in taste. So surely glucose and fructose should be there, because sucrose is there in the sugar cane, right? Sugar cane. So the sweet taste usually comes from galactose. Can't be there because galactose is there in the dairy products. So it should be glucose and fructose, right? Glucose and fructose. So it's glucose and fructose. Right. Even lactose is in milk. Sucrose is in sugarcane. So glucose and fructose. Between which atom is a peptide bond formed? So peptide bond is basically formed between, if you draw it, this is the double bond OOH. This is alpha carbon. There's a hydrogen. Then there's a R or hydrocarbon chain. And there's a NH2 group. And if another amino acid with carboxylic group, alpha carbon, the R group, and then the NH2 was there. This hydrogen of NH2 group and OH of carboxylic group will get together and will remove as a water molecule. This is you called a condensation reaction. What do you call it? It's a condensation reaction. It's a condensation. The condensation reaction, right? It's a condensation reaction. Get it? It's a condensation reaction, right? So once this water, I'm gonna, shall I draw it in another different color then? Easier. So once this bond is removed, once this bond is removed, once this water molecule is removed, there will be a bond between the atoms which are left here now. What are the atoms here left? Nitrogen and carbon. Then that nitrogen is of amine group and the carbon is from the carboxylic group. So there will be a bond. And this bond is the bond between two of the amino acids which called peptide bond. Right? We should call the peptide bond. So now it's a peptide bond. Between which atoms is a peptide bond formed? It's basically the between nitrogen and carbon, right? Nitrogen and carbon, hydrogen and nitrogen, carbon and nitrogen. This is right, carbon and nitrogen, and the carbon is of carboxylic acid, nitrogen is of amine group. So the answer is 5, right? Answer is 5. Hope you understood. Right, come to the next question. Consider the following enzymatic reaction, hydrolysis of lactose, right? Right. Consider the following enzymatic reactions. Lactose converts into hydrolysis. Lactose through hydrolysis is breaking down into hydrogen and X and Y. Sorry, bit went out of the track. So coming back, lactose is converted into X and Y, which is a hydrolysis. So this is the reverse of it. Now this is a different reaction and the top one is a different reaction. But if you understand this is a condensation reaction. When the bond was produced, water molecule was removed. When the bond was produced, water molecule was removed, which you call a condensation reaction. And if you want to break this bond again, you will have to supply the removed water molecule back. You get it? When the bond was forming, one of a water molecule had to remove. That is a condensation reaction. And if you want to break this bond, right? If you want to break this bond, you'll have to supply another water molecule to this, and supplying this water molecule back is called hydrolysis. Understand? Supplying that water molecule back is called hydrolysis, right? So lactose hydrolyze is producing two of the things. It's basically glucose and galactose. If you went into alpha and beta, it's beta glucose plus beta galactose. So the question questions are not up to that level yet, but moving on, they will ask what conformation of glucose and what conformation of galactose are reacting as well. So if you think about the conformations, that's alpha and beta, right? And conformation in the sense there are alpha and beta molecules of glucose and galactose. So out of those alpha and beta, the lactose is produced of beta glucose and beta galactose. So glucose and galactose, of course. On these three, those are easy, right? And if you take it in the conformation, they are both beta glucose, beta galactose, just remember. And this hydrolysis is giving back the water molecule which was removed when the bond was formed, right? Okay. Coming to the next one, 9th question. What is the correct statement given below regarding amino acids? Right? What is the correct statement given below regarding amino acids? A peptide bond is present. Right? What is the correct statement given below regarding amino acid? What is the correct statement given below regarding amino acid? Okay. Peptide bond is present, of course, in no. Amino acid, inside the amino acid, there's no peptide bond, right? Inside the amino acid, there's no peptide bond. If there's a bond between two of the amino acid, of course, there is peptide. So what is correct statement given below regarding amino acids? No peptide bonds are there inside of amino acid. This is somewhat wrong. Okay. Carboxylic acid and amine groups are present. Yes, in amino acid, these two are present. It's a must. Amine group is attached to the carboxylic acid. No. Amine group is not directly attached to the carboxylic acid. It's attached through the alpha carbon. So this is wrong. They're asking the correct statement. Okay. Probably the second one. Let's see. Alpha carbon is a carbon atom which belongs to the carboxylic acid. No. The carbon belongs to carboxylic acid is called carbonyl carbon. Remember this, huh? Carbonyl carbon. Called carbonyl carbon. Remember that. The carbon belongs to carboxylic acid is called carbonyl carbon. Right? It's called carbonyl carbon. So this is wrong. Only some amino acids contain a carboxylic acid. No. It's a must to have a carboxylic acid for all the amino acids. Carboxylic and an amine group is a must because the bond happens to this amino acid and the carboxylic. If it is not present, there is no way to make the bond. So this is wrong as well. So the correct statement is actually 3, right? Correct statement is actually 3. Structure A, B and C of some carbohydrates are given below, right? Structures A, B and C of some carbohydrates are given below. Okay. So if you see the structures A, B and C, these are structured essay questions, right? Would you want me to continue this or shall we come to the industrial? What do you say? Okay, continue with this one. Okay. Yeah, sure. Right. Structure A, B and C of some carbohydrates are given below, right? Now, so this is how you identify the structure. So the number of carbons are 6. So it's a hexo sugar, right? And the next thing is if it is alpha or beta. So in the first one, you see that this is carbon 1. After the oxygen, the carbon next to it is a carbon 1, C1. So if there's an OH group attached to it above the plane, that is a beta, right? So this is a beta uh, confirmation. Now you have to find if it is a glucose or a galactose, right? You have to find if it is a glucose or a galactose. Check for the fourth carbon, right? Check for the fourth carbon. If the OH group of the fourth carbon is below the plane, right? If the OH group of the uh, if the OH group of the fourth carbon is below the plane, uh, that is glucose, right? That is glucose. And if the OH group of the fourth carbon is above the plane, that's a galactose. So this is beta glucose basically. That is how you identify it, right? This is beta glucose. You checked only these two things and number of carbons. That is enough. You already know the shape, right? So you check two things, alpha beta, then glucose galactose here. If it is below, it's glucose. If this is above, there is galactose. So it's a beta glucose, right? It's beta glucose. Second structure. Now this shape is basically fructose, of course, right? If there's like 6 carbons, it is of course fructose. 1, 2, 3, 4, 5, 6, right? 1, 2, 1, 2, 3, 4, 5. See, there are 6 carbons, then this is obviously fructose, and the other one looks like this is ribose sugar and deoxyribose sugar, right? Ribose sugar and deoxyribose sugar is looking alike, but these CH2OH groups, only one CH2OH group is present in ribose and deoxyribose, right? In ribose and deoxyribose, only one CH2OH group is present. So if 2 of the CH2OH groups are present and 6 of the carbons are there, that's a hexose, and it's basically fructose. Right? Looks like a pentagon, but it's a hexagon. So this is fructose, right? This is fructose, right? And it's a beta fructose because number of carbons here are calculated from this side, 1, 2, 3, 4, 5, likewise. So the OH is, so you don't have to worry about the alpha beta of the fructose, just know it's fructose, that is enough, right? So this is fructose. You don't have to identify alpha and beta of the fructose, right? By the structure, you don't have to identify. So structure C, this is glucose by OH here, and this is fructose, right? So glucose and fructose bonding together is obviously forming sucrose, right? So this should be sucrose, right? This should be sucrose, right? So complete the table given below based on the structure ABC. Structure A, name of the carbohydrate, A is glucose. You don't have to go to beta alpha because they don't request it up to now. So glucose. Type of carbohydrate, it's a monosaccharide, right? It's a monosaccharide. It's a monosaccharide, right? And B is fructose. B is fructose. It's a monosaccharide as well. Fructose. Type of carbohydrate is a monosaccharide. Monosaccharide. It's a monosaccharide. Then C is of course sucrose. And type of carbohydrate is a disaccharide, right? It's a disaccharide. Right? It's a disaccharide. From the structure A, B, and C given above, what is the main carbohydrate found in cane sugar? It's sucrose, C. complete the following. So they are asking in the terms of ABC, so you answer it in the terms of ABC as well. So if you want to write sucrose, write C, then after that you write sucrose. Right. Complete the following table based on the observations of experiment performed using glucose and Benedict solution. Right. So the solution mixture Benedict solution plus glucose solution after heating. The color will be brick red precipitate, right? So color will be brick red, of course, brick red. Plant cell wall mainly consists of a polymer made of simple sugar molecules. What is this polymer? So cell wall is made of basically cellulose, right? What is this polymer? It's cellulose. It's cellulose. Write the main type of polysaccharides used to store energy in living organisms. Write the main type of polysaccharide used to store energy in living organisms in the table given below. This is plants. I'm glad they wrote it as veins. It's plants. Right. So write the main type of polysaccharides used to store energy in living organisms in the table given below. Right. So in plants, it's basically energy storing is starch. And in animals, the energy storing molecules is of course glycogen. Right. Glycogen. What is the group of biomolecules formed in the amino acid polymerization? What is the group of biomolecules formed in the amino acid polymerization? Hold on. What is the group of biomolecules formed in amino acid polymerization? Hold on. It's a group of biomolecules formed in it's protein, right? That's easy. Proteins. What is the group of biomolecules formed in amino acid polymerization is proteins. Name a reagent that can be used in the school laboratory to identify the group of biomolecules mentioned in the part B. It's actually part 6. It's actually biurate, right? Biurate. It's a biurate test. 7. An enzyme is a biomolecule that is having a catalytic power. The energy diagram of energy versus the progression of reaction is given for an industrial production process, which is performed using a typical enzyme. Draw the energy curve in the absence of an enzyme on the same diagram given below. So in the presence of, is it in the presence or absence? In the absence of an enzyme. Okay. So in the presence of an enzyme, they choose a different path which has a low activation energy. So this is the activation energy gap for the enzyme. I'm just drawing this. This is not the exact thing you're supposed to draw. I'm just explaining it. So this is the activation energy with an enzyme. In the absence of an enzyme, the activation energy pathway is different. So it's much more larger than this. The energy gap or the activation energy without enzyme is more than this. So you should have to have a higher activation energy gap when you draw it without enzyme. And this is the transitional state. So this is the transitional state in the presence of enzyme. This is the transitional state in the absence of the enzyme. So they are two different transitional states. Transitional state without enzyme is higher. The transitional state with enzyme is lower. And they should start from the same starting point as I have drawn it from the same place, right? And they should end at the same point as well, because an enzyme does not change the reactant's energy or the product's energy at the end, right? They don't change the energy of reactants or the products. They just only change the pathway of the activation energy, right? They choose the low activation energy pathway, so they only change the activation energy I hope you understand. They don't change any of the reactants or the products. So therefore, they don't change the heat of reaction, right? They don't change the heat of reaction because they don't change the energy of the reactants or the products, right? So you don't have to draw this one, this part. Just have to draw this one, right? Have to draw this one, and you can draw this one as well. EA, I'll draw it as EA. So EA is activation energy. Activation energy without enzyme, right? State two factors that can change the activity of above enzyme. So there are many of the factors can change the activity of enzyme. One is pH, the other one is temperature, then the salinity, right? Salinity can change the activity of enzymes. Then the presence of inhibitors, sometimes enzyme inhibitors. Then concentration of enzymes or the substrate concentration. We are asking state two factors that can change the activity of enzyme. Okay, concentration of substrate. No. So activity of an enzyme only depends on the things that can affect the enzyme. So things affecting the enzyme are the pH, temperature, salinity, then the enzyme inhibitors, likewise things, right? Those are not the concentration of the enzymes or the substrates. They will affect the rate of reaction, of course, not the action of the enzymes, right? Second, consider the following dipeptide molecule. 3 bonds in it are labeled as P, Q, and R. Okay, 3 of the bonds in it are labeled as P, Q, and R. Consider the following. Okay, what is the letter in the label assigned for the peptide bond? So as we discussed, peptide bond is between the carbonyl carbon of carboxylic acid and the nitrogen of the amine group. So it's basically Q, right? If you see it, this is the carbonyl carbon, this is the nitrogen atom. So the bond is basically in between those two, that is Q. 2. Name the enzyme group that can be Name the enzyme group that can be to break the peptide bond in proteins. Name the enzyme group. So that is protease, right? Protease. Protease are an enzyme group that breaks the proteins. Protease. Right? Protease. Name a test that can be used to identify the presence of peptide bond in proteins. Name a test that can be used to identify the presence of peptide bonds. Okay. Presence of peptide bonds is identified by biurate. So basically it's identifying proteins, biurate test. Sorry. Biurate. Let's write it. Structure of some biomolecules named as W, X, Y, and Z are given below. So if we check, it's a hexagon, 6 carbons percent. OH of 4th carbon is below, so this is a glucose. And the first carbon, OH is also below, so this is a alpha glucose, right? And that's W. X is also, this is beta, and this is glucose, so beta glucose, right? This is 2 of the alpha glucose together. That's a disaccharide basically. And Y is what? This is fructose. This is glucose. So this is sucrose, right? Yeah, this is sucrose. Sucrose, right? And this is a triglyceride with glycerol. This part is glycerol, and this part is fatty acid. 3 of the fatty acids. So this is a triglyceride. Triglyceride. Right? This is triglyceride. Okay. Name the reagent that can be used to identify the biomolecules named W. W. So this seems to be continuing. You see that? This seems to be continuing. It hasn't stopped. So we don't know the number of it. So we have to assume this is starch. Oh, it's maltose. So if it is maltose, it's Benedict. If it is starch, that's iodine. So as in these cases, you see that the bond has stopped. Right? It doesn't continue from anywhere. So it's not a polymer. It's a disaccharide. Even in this case, it seems to be continuing. You see that the bonds are continuing. See, in none of these cases, it seems to have like continuous bonds. So I believe that this is starch, right? This should be starch. This is starch, right? This is starch. And this is sucrose. This is triglyceride, and that's a beta glucose. Yeah. Name the reagent that can be used to identify biomolecule W. That is iodine. It's iodine. Should be iodine. Which biomolecule mentioned above gives red color in Sudan 3? It's basically the triglycerides. Is it? Right. After writing Z, you can write triglycerides. No? So it's a must to write this Z. So structure of X belongs to which group of carbohydrates? Structure of X. It's monosaccharide, like just one molecule. Monosaccharides. Monosaccharides. It's monosaccharides. 4. Name the reagent that could be used to identify the biomolecule X and write the color. Name the reagent that could be used to identify biomolecule X. Okay, what is X? X is beta glucose as in the structure, but it's a glucose, so Benedict, of course. Benedict reagent. Right, it's Benedict reagent. 5. What color confirms the presence of biomolecule X when it's tested with the reagent? Right, the color that reagent prior to test. So prior to test, it's blue. They're asking the color prior to test because it's copper sulfate in the acidic medium, so it's blue. What color confirms the presence of biomolecule X when it is tested with the reagent mentioned in 4? So when it is tested, it's brick red, right? In the presence of glucose, it's brick red, basically brick red. Which of the above biomolecules is present in beetroot and sugarcane? It's sucrose, right? It's sucrose. Must be sucrose. Proteins are. Is there any fructose in there? No. Beta glucose. Okay. So it's sucrose, of course. Proteins are important type of biomolecules in living organisms. Name a reagent that can be used to identify proteins. It's biurate. Right? It's biurate. Name 2 main shapes of the 3-dimensional structures of proteins. Name 2 main shapes of 3-dimensional structures of proteins. Name 2 main shapes of 3-dimensional structures of proteins. So this is from the old syllabus. In the old syllabus, there were alpha uh, helix and beta plated sheet. Those were the things they are asking, but in the new one, there are three which are fibrous proteins. Then there are globular proteins. And then there are conjugated. There are conjugated proteins, or you call it conjugated proteins, or you call it complex hybrid, right? Complex hybrid proteins, right? Call it complex hybrid proteins, right? Those are there. Enzymes catalyze biological reactions. Draw the relevant energy curves for an enzymatic reaction in the absence and in the presence of an enzyme. So if this is the reactant and if this is the products, this is the activation energy in the presence of an enzyme. I'll take it as EA2. This is the activation energy in the absence of an enzyme. Right. I'll take it as EA1. So EA1 in the absence of an enzyme, and EA2 in the presence of an enzyme. Those are the two, right? Industrial vinegar production is done by the microbial fermentation. The two main steps in the vinegar production can be given as follows. Raw material X converts into intermediate product Y. Then intermediate product Y converts into vinegar. So this is basically ethyl alcohol, right? First step is fermentation, and then the second step is, of course, the vinegar production. Or we call it acetogenesis, acetic acid production. What is the most widely used raw material in the vinegar production in Sri Lanka? It's toddy or the phloem juice of coconut tree. So it should come from here, right? So it's phloem juice. Phloem juice of coconut plant, right? Name the disaccharide in XXX. It's sucrose. What is the experiment used for the identification of X? Benedict test in acidic medium. You should add some acids in acidic medium, right? Right. Out of step 1 and step 2, which step is based on the microbial fermentation? Step 1. Because first step is to produce ethanol. What is the step in the vinegar production process that Acidobacter is involved? Step 2, right? Because Acidobacter is producing acetic acid out of ethanol. If the production process is terminated at step 1, what is the product that can be obtained? Toddy, right? Write the chemical name of vinegar. acetic acid. It's acetic acid. Right. Following tests were carried out to identify biomolecules in a sample of bee honey. State test that produce a positive result with yes and that produce negative result with no. Okay. Okay, bee honey. The bee honey contains Benedict, yes. Iodine, no. Biuret, no. Anhydride, no. Sudan, no. So it's only for the Benedicts, right? Right. Four type of biomolecules that are used in different industries are given below. Answer the following questions based on the given biomolecule. So this is a linear structure of glucose, right? And B is an amino acid, and the R group is a hydrogen, so it's a glycine, right? So out of 5 molecules, we remember to draw the structures. Glycine is the first one, and it is the simplest one. Okay, what biomolecule contains or contain an aldehyde group as a functional group? Right? What biomolecule contains aldehyde group as a functional group? So they have C. They don't. They do. What is D? It seems to be starch, and they have. So it's A and D. AD both, because they are both carbohydrates. All the carbohydrates have aldehyde groups, either aldehyde or ketose group. So this seems to be starch and this seems to be glucose. So they both have aldehyde groups. So only sucrose have ketose, ketone groups. Only the sucrose are the ketose, and the fructose are also ketose sugars. Fructose and sucrose are the only ketose sugars which contain ketone groups in our syllabus. What biomolecules contain a carboxylic acid group as functional group? So out of this, it's of course B, right? Carboxylic group. It's amino acid. B. Which biomolecule provides positive result for the iodine test? That is starch. D. I'm sorry, this is D. Name a suitable test to identify biomolecule B. What is biomolecule B? Biomolecule B is amino acid, and identification test is actually an anhydride. It's anhydride. Identify what biomolecule or its derivative given above contains in each industrial product mentioned in the table. Identify what biomolecule or its derivative given above contains in each industrial product mentioned in the table. Write the letter that represent each identified biomolecules in the following table. Okay. Right. So cotton threads, letter that representing the biomolecules. So in the cotton threads, it's which biomolecule is there in the cotton threads? Not this one. This one. So it should be. There's another molecule we didn't see. There's a C as well. What is this? CH3, CH2 continues for 14 and C double OH. This is a fatty acid. So did I miss it in any of the other questions? What biomolecule contains carboxylic acid? So even C, B and C. Which biomolecule provides positive results for iodine is only D. Yeah, this is okay. Yeah, that's all good. So cotton threads. it should be starch, right? Should be starch, because in cotton threads there cannot be any fatty acids, glucose or amino acids. It should be starch, which is D. D, 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 D. D. Okay. So, out of these, fatty acids can include in soap, because it's basically triglycerides and sodium hydroxides which are reacting, but free fatty acids can also be there, and uh, it can relate to soap. Sugar. Sugar is sucrose, and do you have any sucrose here? It should be A, because sugar contains glucose and fructose, right? Should be okay. Seems to continue. Right. This is the last one, right? Sucrose is a disaccharide. Name two monosaccharides containing sucrose. It's glucose and fructose. What is the main biological function of sucrose? Sucrose is the main sucrose is the main carbohydrate in the phloem juice, and there are three of the things. Carbohydrates are mostly stored as starch, and when it's carried through the phloem juice, it's converted into sucrose, and in the photosynthesis they are formed as glucose. These three things are there. So in the photosynthesis, carbohydrates are produced as glucose and stored as starch, and when they need to transfer it, or when they need to carry it through the phloem juice, they convert it into sucrose. So what is the main biological function of sucrose? Is to transfer carbohydrates in the phloem juice, right? Transferring material of carbohydrate in phloem juice. Transferring material of carbohydrate in phloem juice must be the answer. Right. So we have finished biomolecules up to this level, and we'll continue with the industrial the next day, right? And if you have anything else to clarify, just put me a text, right? We will do. So good luck, like you are getting really closer to your exams. Hopefully you will all do fine, right? Do your best, do your maximum, and show that who you are, and gain your respect, do your best, and I believe in you. That is the first thing. I believe in you, that you can do this, you will do this, and you will show everyone that who you are, right? So let's see, right? It's your time, it's your moment. Okay, so shall we wind off for today? Let's do. Right.